Hello, my name is Michael, and I'd like to do a little demonstration of what we can do with stargazing uh, indoors when the weather is not cooperating as it has been not doing here in Dallas Fort Worth over the past couple weeks. Unfortunately, we've had a string of pretty crazy spring weather, so outdoor observing has not been something that we can do, but I like to do a virtual tour if we can. And I like to go back and look at the lunar eclipse that happened a few weeks ago and explain a little bit about what a lunar eclipse is. So, we see here a virtual reality of our night sky, but I first want to explain what a lunar eclipse is. And to do that, I'd like to go to the internet and show you what an eclipse looks like. So first we have to talk about the phases of the moon. And we know that the moon revolves around the earth, but it doesn't do it in a flat line. What it does is it will orbit around the earth, but the orbit is tilted. So it will change its position periodically. So it may not always line up with the earth. So what happens in a 28-day lunar cycle when the moon is between the sun and the earth? We call that a new moon because we can't see it. There's no reflection that is shown to us on the night side of the earth, which is here. When the moon is full in the middle of the lunar cycle, we see the full face of the side that's facing us being reflected in the sunlight. So we see that at night during the full moon. And then, of course, the phases in between, waxing, crescent, first quarter, waxing gibbous. Then it wanes to the third or to the final quarter, till waning crescent, until the new moon again. So what happens when in a new moon, in a full moon, when the moon is not out of alignment with the sun and the earth, when it's directly behind the earth? Well, we have a lunar eclipse. So right here, we see that the moon is behind the earth. And this isn't to scale, but the moon is in the full moon phase of the cycle. However, it is lined up behind the earth. So the earth is eclipsing the moon. So the earth's shadow, called the umbra, fully engulfs the face of the moon. We see here that the earth's shadow is expressed in two different terms, the penumbra and the umbra. And the umbra is the greatest part of the lunar eclipse. But during the penumbra, we see the Earth's shadow slowly move across the face of the moon. Here's the orbit, sun's rays, and it creates this dark little shadow area where the moon, during a lunar eclipse, aligns. Now, that's what happens during a lunar eclipse. It happens during a full moon. What happens during a new moon? Well, you may have guessed, a solar eclipse, where the moon lines up perfectly between the sun and the earth, and that creates a solar eclipse. So only a part of the earth is in the moon's shadow because the moon is, of course, smaller than the earth, whereas the earth is larger than the moon. So when we have a lunar eclipse, we see the full moon eclipsed completely, whereas the earth is never eclipsed completely. That would be catastrophic. So we only have a small path on the Earth's surface whenever a lunar eclipse happens. But again, that happens during the new moon, in this phase. So now, I'll show you what a lunar eclipse looks like when it happens. So this is the evening of the 15th, Sunday evening, And if you were lucky enough to be in a part of the world where the lunar eclipse was happening, but also where there was not a thunderstorm happening, which is what happened in my house, you would see a beautiful clear sky. This is around 8:30 p.m. You see some stars poking out. Twilight's upon us, and the sun is sinking. We're approaching blue hour, and the moon is peeking over the horizon. If you have an unobstructed view of it, it's pretty low on the horizon. And this lunar eclipse happened to begin very early in the evening. So, for it being a Sunday night and you had to work tomorrow, the next day, you got to see a pretty good amount of the lunar eclipse before bed. So here's how the moon looked. It was a big supermoon, so it appeared large in the sky, but it's no larger than at any other point in the sky. And we'll just move forward into the night, minute by minute, and we kind of start to see a little bit of dimming here on the bottom of it as the moon moves into that penumbra part of the Earth's shadow. And we see it kind of starting to get a little dark there. So, moving towards 9:30 Central Time. And we kind of see the moon dimming quite a bit there. Let's scroll out. So, it's not super noticeable yet, but if you had binoculars or a telescope pointed at the moon, you would start to see the transformation. We'll go a little bit further. Okay, now we see the Earth's curve, the shadow of the Earth's curve starting to move across the face of the moon. And this is how we know that the Earth is not flat, because a flat object does not cast a curved shadow. So we'll move a little bit further along, and we are approaching totality, which is when the moon completely enters that umbra, the deepest part of the Earth's shadow, and it's starting to move across it. It kind of looks like the phases of the moon as we go further along. And it's hard to tell, at least from this particular program right now, that things are getting darker. The moon, the full moon, cast a bright light in the night, and I'm sure you may have noticed if you ever looked up during a full moon, it is very bright. It's the brightest object in the sky, apart from the sun during the day, of course. The moon is the second brightest object, and the full moon is when it's at its peak brightness. So, when it gets closer and closer to being fully eclipsed, the night sky gets a little bit dimmer. And you start to notice around you, your moon shadows are disappearing, things are getting darker. So now, as we approach what is known as totality, right around 11:30 p.m. on Central Standard Time, now notice, real fast, how all these stars have suddenly appeared. And that's what happens when a very bright source of light is taken out of the sky. If you live in an area where there's minimal to no light pollution, and during a new moon, you'll see all the stars in the sky. But when a full moon happens, you see a little bit less of that because the full moon washes out a lot of it. So during a lunar eclipse, we see those stars poke back out as if it were a new moon. So now about 11:30, we have basically begun totality. So the moon is fully eclipsed by the Earth's shadow. It is directly behind the Earth, opposite the sun, and now we see the moon start to turn a little red. The reason that happens is because the Earth's atmosphere, as light passes through it, refracts all the blue light from that light from the sun, and all that's left when it hits the moon is reflected back is red. We see red light. So that's why during a lunar eclipse they call it a blood moon, because it turns red. Let's zoom out a little bit here, and I want to show you something. You can kind of see, now this happened late spring, early summer time. During the summer, you can see the band of the Milky Way start to rise over the horizon. And that's because we see it more, we see the core of the Milky Way, I should say, in the summertime, because where we are in the sun's orbit, we are between the sun and the core of the Milky Way. So at night, when we are facing away from the sun, we see that big bright band of light from our home galaxy. In the wintertime, in the northern hemisphere that is, when we are the opposite side of the sun from the core of the Milky Way, we don't see that core. We see some of the Milky Way, the other arms of the Milky Way in which we can observe out into, but it's not that thick band that we see in the summertime. So when the moon is eclipsed in a lunar eclipse, we start to see a little bit of that band starting to come over the horizon there in the southeast. If this were to happen later in the summer, that band of Milky Way light would be a little bit more vertical, but because it happened during this time of the year where the Milky Way is beginning to rise the way it is, we see it as more of a horizontal band. It's more parallel to the horizon. So that's what happens when the full moon is eclipsed. So we'll continue on a little bit more. Again, those stars are still out. And it's still that awesome shade of red there. Very pretty. Very ominous if you're an ancient person from a time where science wasn't as developed. Things weren't easily explained by our tools and instruments and ways of thinking. The lunar eclipse was perhaps an omen to some cultures, foreseeing drought, famine, war, especially, red being the color of blood. So a lot of people thought the lunar eclipse meant there would be death. We know now that that is not the case. But back then, it was pretty scary. So now as we get closer to midnight in Central Time, we kind of start to see this bottom edge lighten up a little bit as the moon moves along in its orbit around the Earth. The Earth's shadow is now starting to leave. And if you notice, just then, those stars disappeared because now the moon is starting to reflect that sunlight back towards Earth. So it's becoming brighter and brighter. As the shadow of the Earth starts to move away from the moon, out of the umbra, back to the penumbra, on the opposite side, we see the opposite lunar phases as it gets later and later at night, and the moon slowly becomes full again. And it goes on throughout the night along the sky. And that is what happens during a lunar eclipse. And if you're lucky enough to see that, congratulations. I was not, but that's okay. I'd like to show you a couple other things before we end this demonstration. We'll go a little bit later into the early evening. So the moon is starting to arc downward towards the west, as we know the moon does, same as the sun. But the planets, the other planets in the solar system, follow that same path along the sky, and that's called the ecliptic. And that is the path in which the moon, the sun, and the other planets of the solar system move. And the ancient Greeks called these planets, which meant wanderers, translation, because they moved differently compared to the stars in the background. So now you know that a planet is a wanderer because it moves differently. So we'll get into the early morning, and we see some of our other solar system neighbors. We'll start with Saturn. Saturn's rising a little bit sooner than the other notable planets here. We'll just go take a look at Saturn. Scroll in. And here we see Saturn and its many, many moons and its many, many rings. Titan is its biggest moon, and you can see that through a telescope. You can see a few other bright moons if you have a powerful enough telescope. But there is the crown jewel of our solar system in all its glory, and it's beautiful through the lens of a telescope. If you ever get the chance to look through a telescope at Saturn, you have to do it. It is a crowd favorite. We'll move on to another planet. Let's check on Mars. Mars is the red planet where we have a lot of robots right now. It's one of our nearest neighbors. Certainly a lot of scientific intrigue surrounding Mars. And there's Mars right there. It only has 2 moons, Phobos and Deimos. They're very tiny rocks that orbit it, but they are moons nonetheless. And Mars is a very funny planet. It has solid ice water at its poles, but we hope that there is maybe some liquid water underneath the surface, perhaps. And if that's the case still, maybe there's life. Let's move on from Mars and we'll go to Jupiter, the biggest planet in the solar system, named after the Roman god, king of the gods, Jupiter, Zeus in the Greek mythology. Jupiter has 4 main moons that are easily seen through a telescope. These are the moons that Galileo first noted when he looked at the planet through his telescope, so they are now called the Galilean moons. Callisto, Ganymede, Io, and Europa. All very dynamic, different worlds, very interesting places. Jupiter has many more moons than that, of course. A big planet of that size has a big mass and a big gravitational pull, so it has many, many moons. And notable on Jupiter are the red and beige bands of what appear to be clouds in its atmosphere. Those are giant swirling clouds and hurricanes and storms that happen on its surface. It's a very violent place to be, but very pretty place to look at. And that concludes our quick little demonstration of what a lunar eclipse is and a walkthrough of some of the planets in our solar system. Thank you.